I am very excited to introduce our NASA and JPL Solar System Ambassador, Matt. So thank you for joining us today, Matt, and I will let you take it from here.
Great. Give me just a minute.
Yeah.
There we are. Well, thank you for having me. I want to explain what the Solar System Ambassador Program is first, if
Sure.
I could. Basically, since the space program doesn't always grab headlines anymore, but we're still doing plenty of interesting things out there, NASA and JPL oversees everything that NASA does that's unmanned, opted to have a volunteer educator outreach program, and they
Oh, Matt, it looks like you are
Yep, it looks
muted.
like I was muted
Okay,
there.
sorry about that.
No worries. The so I'm sorry. They wanted us to be sort of volunteer educators to get people up to speed on exactly what it is the space program's doing. They train us remotely so that hopefully we know what we're talking about. And honestly, it's been a lot of fun. I get to go to museums and libraries and schools and stuff, and talk to people who are really interested in space, because there's a lot of it, a lot of interesting things to do about what we're doing. Oh, anyway, let me get started. Uh, Going back to the moon. Obviously, going to the moon is something we've already done before, but NASA has been making noise about going back recently. And of course, there might be a natural question, why? Well, why did we go to the moon in the first place? What did we do there? What do we hope to do when we go back? Um, all of these are good questions, and I'm going to have to give you a little bit of a history lesson to talk about why we went to the moon in the first place. Back a few decades ago, there was something called the Cold War. When the World War II ended in 1945, a very few number of countries emerged that were called superpowers. They were nations that had lots of money, lots of resources, lots of influence, and the biggest players on the global stage quickly became the United States and the USSR, the Union of Soviet Socialist Republics. They were kind of opposed in ideas about how they should run politics and what we should do with money. And that, unfortunately, caused a deep divide between the two nations. And I say unfortunately, not just because of the human reasons behind that, but because we worked so well together during World War II. When World War II ended, see, World War II saw a lot of improvements to rockets. Germans figured out a lot of things about how to make liquid-fueled rockets, and they used them to drop bombs on the Allies. Obviously, when Germany was conquered in 1945, the rocket scientists basically decided among themselves which superpower they'd go with, whether they'd go with the United States or the Soviet Union, and we, during Operation Paperclip, brought all kinds of plans over, all kinds of rocket scientists over, and we didn't really know what to do with them for the longest time, honestly. We had them conducting research in aeronautics and rocketry, but they had no real direction. But all of that changed in 1957. This is Sputnik I, as it turned out. It was just Sputnik originally, but it turned out to be the first in a series. And it was the first artificial Earth satellite. The Soviet Union launched it in 1957, and it caught everybody by surprise. This thing is pretty small. It's only about 3 feet across and only about 180 pounds. And it didn't do much more than beep, but it scared the pants off the United States. Because we were building nuclear weapons and we knew they were building nuclear weapons, if it turned out that their rockets were better than our rockets, they might be able to drop a bomb on our heads, and we would not be able to do anything to retaliate. So the question naturally arose, are our rockets as good as the Soviet Union's? And it became a question for the entire world, because a lot of allies that had come with us wanted to be assured that our rocket technology was every bit as good as the Russians were. So we accelerated a rocket program. We hired 7 people called the Mercury 7 to stand in tinfoil spacesuits and look like the brave people who would protect us from those nasty Russians. But while all this was happening, of course, we were trying to figure out what rockets were all about, and we had some very embarrassing failures. There are a number of them, but one of them, just to illustrate how embarrassing some of these were, was known as the 4-inch flight. They put a rocket together with a dummy capsule on top of it, loaded up all the fuel in the software, and pressed go. And the thing, thundered and roared as rockets do, lifted about 4 inches off the pad, and then shut down. And the thing settled right back down on the pad, And while everybody was sitting there waiting what to do with this mostly fueled rocket sitting there on the pad, all of a sudden the parachute pops out of the capsule, and now it becomes a real problem. Okay, you've got lots and lots of explosive fuel sitting there on the pad, so nobody wants to get close, and it's got a parachute on top. So if the wind catches that thing and blows it over, it could destroy lots of things. All kinds of ideas were floated out there. What could we possibly do to approach this thing safely? Somebody suggested using a rifle to shoot a hole in it and trying to let the fuel escape as it boiled off. Thankfully, someone remembered that the rocket was set to open vents automatically after a while, and that would let those fuels boil off. So they waited a few days for all that fuel to boil off, and finally approached the thing and tried to figure out what went wrong. It turned out that the arms holding the rocket down to the pad that are supposed to break off as a result of the rocket's force were a little bit too strong, and they didn't break off. And the rocket wasn't breaking away as quickly as it should. Right. So the rocket thought something was wrong, and its software told it to turn the rocket engine off. That meant that the rocket shut off and fell back down. Well, the capsule got the signal that the rocket shut off. So it went through its paces and everything it was supposed to do, culminating with jettisoning the parachutes and floating back down safely to the Earth. It had no idea that it was still attached to the rocket. But it did everything it was supposed to do. These are the kind of things that we look at after they're done, and when they happened, it's kind of hilarious, and it should have been obvious. But before it happens, sometimes you have no idea what you should have known, and that's the kind of embarrassing failures the United States was having at the time. The Soviet Union didn't realize how earth-shaking the idea of the Sputnik was for the longest time. But when they did, they really pressed the advantage. They had parades with rockets going, as main attractions in the parades. Khrushchev famously came into the United States, the United Nations, and banged on his desk with a shoe to get attention and announced to the United States that we will bury you. And the United States took this kind of personally. So we had to prove that we could do every bit as good as they did. And while we were still fumbling around, the Soviet Union launched Yuri Gagarin into space. He was the first human to orbit the Earth, the very first manned mission. And this shook us up. I mean, obviously, not only could the Soviet Union launch a beeping sphere into space, but they could launch people. And this was kind of earth-shattering. President Kennedy went to his advisors and asked people, what should we do to catch up to the Soviet Union? What would make a clear goal for us to reach and still be far enough away that we can catch up and pass them if we have to? And their answer was unanimous. We have to land somebody on the moon. Everybody will know whether we did or we didn't. And it'll give us enough time, and that's far enough out. So Kennedy goes out and gives a public speech and explains to everybody, we're going to get to the moon by the end of the decade. Now, when he gives this speech, right, it's a little bit crazy because only 2 human beings have ever been off the planet at this point, one Russian and one American. If you try to get a sense of how far they've gone, what I did when I tried to give this lesson to my wife's students, she was a school teacher at the time, on the scale of a 12-inch globe, which they had in the classroom, you've had one person go around and one American just hop down 1/8 of an inch off the surface and a few inches downrange. That's it. That's the total human experience in space. Now, Kennedy says we're going to go to the moon by the end of the decade. On this scale, a moon is about the size of a tennis ball. So I would ask the kids, how far away should I put this tennis ball in comparison to the globe to represent the distance between them accurately? And you start a few inches away and slowly back away. By the time you get to about 6 inches away, a lot of them are telling you to stop. By the time you get about 2 feet away, they're all screaming at you to stop, right? But at that scale, the two need to be placed about 30 feet away from each other, clear across the room, right? All of that, there's nothing in between the two either. We've got to keep a little tin can of people alive to make all that trip all the way there and back, obviously, and back is a big part of the mission. So the amazing thing, of course, is that we did it. This is a picture of Neil Armstrong, and we don't have many pictures of Neil Armstrong on the moon, simply because Neil Armstrong was carrying the camera most of the time. If you look at most of the missions, the pictures we had from Apollo 11, most of the pictures are of Buzz Aldrin. And that's just fine. Obviously they had important stuff to do on the moon, and taking pictures is an evocative and pretty and amazing evidence of what we've done. But it's, by itself, they had lots of studying to do that didn't involve taking pictures, is all I mean to say. And let's see, let's move on. As Apollo lasted for, from landing on the moon to the end of the Apollo program was 3.5 years. Okay. And in that time, we landed 12 people on the surface of the moon with 6 different missions. Each one stayed longer and longer. And by the time we got to Apollo 11, the astronauts only spent about 15 minutes on the surface. With Apollo 17, all totaled up, they spent about 3 days exploring the moon. That last mission ended up leaving at the end of 1972. Okay, and that Congress canceled Apollos 18, 19, and 20. We didn't end up using them, and the flight hardware is currently on display in the various space centers around the country. But we never actually used them. So when we finally ended the Apollo program, NASA had all kinds of follow-up ideas. They wanted a space shuttle and a permanent space station, and they wanted to be able to construct spacecraft in orbit to go to Mars. Congress looked at the price tag and they went, whoa, you guys, this is too much. Pick a thing. They finally picked for NASA and said, look, you get a space shuttle, and you have to play nicely with the Department of Defense, or you don't get anything. The space station idea was later revived as the ISS, but at first Congress was hesitant to do even that. But NASA's big question with the space shuttle, and of course with the ISS, is what do we do next? For 30 years, we spent time in low Earth orbit without any real goal in mind, other than doing research and just figuring out what space travel was all about and how to do manned space travel. And it looked like the moon was pretty inhospitable. All of the minerals that we saw that were brought back with the astronauts were completely devoid of water. If you look at minerals here on Earth, a lot of minerals have water as part of their composition, and these minerals had nothing. And so it looked like the moon would be a pretty awful, terrible place to go, or at least difficult to survive there, as if space wasn't hard enough. But as it turns out, one of the last discoveries made by the Apollo mission would be a piece in all kinds of information that would change what we thought the moon was about. Right? Most of the moon just looks like this lifeless gray. We've all seen pictures. But Apollo 17 returned this picture and some samples of something orange on the surface of the moon. And that really surprised them. You can hear it in the voice transcripts. Holy cow, it's orange! They really didn't expect it at all. They didn't know what it was. What on earth is this orange thing? Let's see. To explain what that orange stuff is, I'll get to that. It's true that water doesn't stick around on the moon too long when light hits it. Okay, when it boils away instantly. You need a certain amount of air pressure to keep water in a liquid state at temperatures like we're familiar with, where liquid water exists. If that pressure doesn't exist, the water just boils away. It's the moon's gravity is also too weak to hold on to water molecules once they escape as gas, so they won't stay down. But what about places that never see sunlight? It turns out that there are places on the moon that don't. If you go down towards the poles, for example, the moon never gets very high in the sky. I'm sorry, the sun never gets very high in the sky. And because the sun doesn't get high in the sky, sometimes sunlight never gets to the bottom of craters near the poles on the moon. Right? The temperature there never rises above negative 250 degrees Fahrenheit or negative 157 degrees Celsius or so. We knew that comets occasionally delivered water to the Earth. And there's some hypotheses that even the oceans, as we see them on the Earth, were the result of cometary water that was eventually delivered to our planet. Could it be that there were ices still trapped on the bottom of these craters that never see the light of day? and would never get a chance to boil off. This is Chandrayaan-1. This is a mission sent by India to go to find out if there was any water still trapped on the moon. It had an instrument called the Moon Mineralogy Mapper, and it was just there to look for the makeup of minerals on the surface of the moon, including some scans in the near infrared that would be able to find water molecules. So the mission only worked for about 300 days out of its 2-year mission, but it was still able to turn up water on the surface of the moon.
That's amazing.
Yeah, it really stinking is. And it's estimated 600 billion kilograms or 160 billion gallons of the stuff sitting at the south pole of the moon in ice. Right? You remember that orange soil that I talked about earlier?
Yeah.
It was orange because that is volcanic gas, volcanic glass, not volcanic gas, glass, volcanic glass that rose up from the mantle of the moon, right?
Yeah.
As magma or lava does here. And studying that glass found out that there was water bound to the molecules in the volcanic glass, which implies that there's water somewhere between the mantle and the surface. And it got picked up somewhere along the way as this stuff rose to the surface and became rock. So how far is it down is a natural question. Even if it's right there at the surface near the equator where the Apollo missions tended to be, how far down is it? And how much of it is there? If it's not buried too deeply, we could just scratch the surface, dig up some ice, and use it for our lunar colonies, right? That'd be fantastic. This probe started to answer that question kind of a sideways way. This is Lady.
Hold on. Sorry.
Yep,
Can I, before you move on to that
interrupt.
slide, can we go back to that picture?
Sure.
We had a question about that picture.
Yeah.
So Tina was wondering in that picture, those 3 craters that are in a row, right in the middle there, are those from a meteor bouncing off of the surface? That's
a very good question. Actually, no, unfortunately. Craters aren't round because the meteors that hit them are round. When meteors hit something big like the moon or the Earth, they tend to hit so fast that they explode. And what you see as the round feature of a crater is rock that got caved out in the explosion. Right?
Very nice.
But what's also the case is that if rocks pass by something massive before they hit, like pass by the Earth on the way to the moon or something like that, the tidal forces of the body that they pass tend to rip those meteors up into roughly equal-sized chunks. And it's possible. We'd have to test to find out. We found a number of places on the moon and on Mars where it is the case. But where you see roughly equal craters in a row like that, oftentimes it's the same body that got ripped apart before it hit. Okay.
So it's 3 separate pieces from probably the same body hitting at the same time.
Right.
Just happens to be in a row.
Just happens to be in a row.
Very
right, exactly.
Nice.
It's weird, but space is weird.
Yeah, that's cool.
I should also mention, this is not a picture of water. This is a picture of where water was detected overlaid onto a picture.
Got it.
Right. So it's not like you would look at the moon and see these blue pools below you.
Yeah, it's not like lakes or yeah.
Right. The different colors correspond to the different amounts. So the light blue is actually more water than the deep blue, if that makes any sense.
Great, thank you.
Okay. Now, when it came to trying to find if there was ice under the surface of the moon, right? This is LADEE here. LADEE is short for the Lunar Atmosphere and Dust Environmental Explorer. And they found themselves asking the question, hey, if there's ice under the surface of the moon and we don't have any shovels handy, how can we find out what's under the surface of the moon? And they realized that the Earth and the moon plow through meteor swarms every once in a while. And if we look at the moon while these meteor swarms are happening, can we find any evidence of water ice being kicked up? And it turned out that they were able to determine that the top 3 inches of the lunar soil, which they call the desiccated layer, is completely dry. But water can be found all over the moon at depths below that. Right? They were able to.
Oops, sorry, it looks like you are muted again. Okay.
Yeah. They looked at 40 meteor swarms, and every single one of them kicked up ice in detectable amounts. So what's our next step? Oh, I got to reselect the slideshow here. It bumped me off for some reason. There we go. Well, what's our next step? Well, Apollo was designed to get to the moon first. I realize I don't have a video here because this is hard to have some kind of picture to go with.
Oh, thanks.
Apollo 1 wanted to get to the moon first. The whole thing was about beating the Russians, right? And so the engineers and the technicians and the scientists and everybody who put that all together were allowed to waste everything but time. They could build tremendously expensive hardware and not even worry about, well, what are we going to do when we get there? They just wanted to get there, right? That was the big important thing. So what we ended up with was a rocket that was great for getting us to the moon in one-shot bursts, but not very effective for staying there and really learning about the what the moon is like close up and for long periods of time. So what do we need to do if we want to move to the moon, to go back to the moon, to stay? And honestly, I think that's what our emphasis should be. A lot of questions about why we go into space ask, well, what could we find in space and bring back that would be worth the cost of going there? I think this is more about giving humans more options and more places to be. And if you look at the old world, for example, and how it was colonized, when Spain and Portugal sent their explorers over, they came back with huge amounts of gold and ended up bankrupting their economies because they brought back very, very rare and valuable items that were all of a sudden all over the place and much easier to find and worth a lot less. So it destabilized the economies of those countries. But when the English and the Dutch and the French sent their colonists over, their colonists sent back relatively mundane things like furs and tobacco. But we were the English and the Dutch and the French went to establish colonies to stay, and we're still reaping the benefits of that now. I would say hundreds of years later, in terms of what they tried to set up. Okay, to go back to what we do now. Okay, this is NASA's list of Artemis firsts. Right, it's the first phase, which lasts from now until 2024, is supposed to basically find out what's going to be involved in setting up a permanent presence on the moon. We have to nail some things down, absolutely. After 2024, the construction of the lunar base itself is supposed to start, and we want to have that permanently manned starting in 2028, send up new astronauts once a year, and they hang out there the entire year, and we swap out crews. Right? So it would be absolutely amazing if we could make that work. But we need to find some stuff out first. First, I'm going to go through these things kind of one by one. The first step is what NASA calls its Commercial Lunar Payload Services, or CLPS program. They want to spend $400 million with private businesses to figure out what kind of technologies and techniques we need to get to the moon. The missions are starting this year, and there are 14 companies, I want to say, yes, 14 companies that have been chosen to build hardware for NASA as part of this contract that they're spending. Innovative Machines and Astrobiotic are starting this year, and this is the Polar Resources Ice Mining Experiment, or Prime 1. It's going to be looking for ice below the surface. So if we're right about ice existing just a few inches below the surface of the moon, it's going to be a proving ground for getting that ice out, right, extracting it and making it useful and so on. Astrobiotics lander is going to be measuring the amount of water and where it collects under the surface, as well as determining whether we can mine methane from the surface, from the lunar soil. Methane would be tremendously useful because methane is rocket fuel. And if we can refuel rockets on the moon, we don't have to carry all the fuel we need there and back. So that would represent a tremendous savings in terms of the kind of rockets we have to build and how much we can pack onto the mission when we go. It's also going to measure things like radiation levels and evaluate how the lunar soil reacts to different changes, like punching it really hard or heating it up or adding chemicals to it or whatever, and how we can react with it to create useful materials right out of the soil on the moon. Following on these CLPS missions is Viper. And Viper is the Volatiles Investigating Polar Exploration Rover. It's actually going to be a rover to explore the poles of the moon and find out where the biggest deposits actually are. We have sort of rough mapping areas based on the map that I showed you earlier, where that ice and water might happen to be, but this will really nail it down and give us a solid idea of, basically drill here or get your ice pick and bring it over here. It's not much to look at, I admit. It's not very exotic looking, but that's partly because everything has to be kept inside a box to keep the inside warm. It's going to be in permanent lunar night. So, and that night gets cold. Remember I said it dropped down to 250 degrees below zero. So it's got everything in a box to try to keep it all heated up. That box is about 5 feet tall, 5 feet wide, and 8 feet long. So about the size of a golf cart, to give you a sense of scale. And it's going to be using a drill to analyze different parts of the water and figure out what's fit for human consumption, or what we need to do to make it fit for human consumption. It's supposed to launch in 2023. We'll also have other missions running at the same time. One of the payloads carried with the CLIPS missions this year is Capstone. Capstone is the size of a microwave, and it's going to be sitting in a very special orbit. That orbit, if you want the NASA technical speak for it, is called a near rectilinear halo orbit, right? Which all sounds very, very fancy, but it's basically at a balancing point between the gravities of the Earth and the Moon to make transition back and forth between them much easier. That's where we want to put a space station called the Lunar Gateway. It's smaller than the ISS, but it will be manned. And the idea is basically that we will launch a capsule to the gateway. A lander will be permanently docked there. Astronauts will transfer from the capsule to the lander, and they'll use the lander to get to the surface. And then when they're done doing their thing on the surface, get the lander to go back to the gateway and transfer back home. The capsule will carry 4 people, and the lander carries 2 of them.
And were those solar panels on the?
Yes, they are.
Okay.
Well, I guess this thing is only about the size of a microwave, so it's
Okay.
going to stay in orbit around the moon. I'll show you a diagram of what that orbit looks like in just a bit.
And then the robot before, since it's in shadow all the time, how is it powered?
Oh, wow, that's a very good question. It's got solar panels on it, so it charges up batteries as part of its initial mission. It starts out several weeks outside near the poles, getting the lay of the environment, and then several weeks inside the permanent shadow, and it goes back and forth.
Okay, so it'll just go back in and out of to get power and things.
Right.
Great, thank you.
It's normal for. It's a very good question, actually. It's normal for rovers or space probes that need to stay warm because they're very, very far from the sun to be nuclear powered or something like that to stay warm. And this actually uses batteries.
Yeah.
Okay, so this right here is Artemis I. Artemis I is going to be the first test of the Space Launch System all strapped together, and it's going to be completely unmanned. We've been having tests of individual parts, and some of you may have tuned in last week to see that the core of the Space Launch System was tested. The test, they wanted to keep it on for 8 minutes, and they ended up shutting it down after just 1 because one of the hydraulic pressure units was registering low, and they automatically, they set up the software to shut everything down with much more sensitive requirements than they knew they were actually going to need. And NASA's position right now is that had this been an actual flight article, everything would have been fine. But they haven't done the full 8-minute rocket test yet. Hopefully they'll figure out whether they need to do that test or not soon, because this Artemis I is slated for November of this year.
That's pretty soon.
Yes, it's very soon. We really, really hope that this works, right? Just a word about the SLS and the Orion capsule, which sits on top of it. It's the most powerful rocket that NASA has ever built. What you see here in this diagram, just to get a sense of scale, is the Saturn V on the left, which was used to take us to the moon during the 60s and 70s. It stood at 363 feet tall. It's absolutely enormous. Huntsville, Alabama has a space center with a vertical Saturn V, and I have never seen it in person, but the pictures that they have of it sitting out there near the parking lot next to the little big cars next to it is just breathtaking to me. I want to see it in person someday, but I haven't gotten there yet. The space shuttle, of course, is there in the middle. The crewed version of the SLS is there on the right. And the crewed version is shorter than it puts out more oomph than the Saturn V did. It's shorter than the Saturn V. The cargo version of the SLS, which will be used to launch the Lunar Gateway and so forth, is taller than the Saturn V. And I don't have a picture of that for scale, but it's just an enormous thing. It's a little breathtaking. This is the Lunar Gateway. Compared to the ISS, it's not that big. but it's only meant to be manned by 4 people at a time. Let's see, I have my notes here about the Lunar Gateway. Let's see, yeah, it's balanced between the Earth's and the Moon's gravity. I mentioned that. It's also the lander's home. It's going to be docked to a different docking port from the capsule in between missions. And it's set up to take long looping orbits around the Moon. Right, here's a diagram, so to speak, and the distances between the Earth and the Moon are not to scale, but it gives you an idea of the looping orbit that the space station is going to make around the Moon.
Very nice.
Yeah, these
and it's like those kind of all of those ovals around the Moon are where it's going to go.
Yeah, the green orbit that you see there, South L2.
The green, okay.
Is basically its main orbit. That's where we would like to keep it. But it's got propulsion units on it, so it can change its orbit to other ones, depending on where on the Moon we happen to want to land. Different kinds of orbits represent different kinds of fuel savings. So it's versatile enough to be able to change if we realize, we want to move to a higher latitude area, or we want to move to a different pole, North Pole versus South Pole, or whatever you like. On the Moon, we may want to shift the orbit. Obviously, if we want to set up a station in that orbit, we're going to have to assemble it. So, in January of 2024, we want to launch the first 2 pieces of the station, what they call the PPE, the power propulsion elements. Basically, get power and rockets, and the habitation and logistics output segments where people are going to hang out. And that's where we're going to start building a lunar outpost, or a permanent place around the Moon that's going to be manned. Obviously, in 2028, we want to move a permanent lunar outpost to the surface, but this is a start. Next on the docket is Artemis II. That's going to be the first manned mission of the Orion capsule. It's meant to take people to the Moon. This mission's supposed to last 10 days, and it won't have a lander, so it's not going to actually set down, but it's going to orbit the Moon at 4,000 kilometers up, which means that it will send people further away from the Earth than humans have ever been.
Wow.
It's supposed to be launched in August of 2023. Again, assuming that the schedule holds with all the testing that they want to do. But finally, the biggest mission, the one that everybody is excited about, is Artemis III. That's going to be the first crewed landing to land on the Moon since December of 1972. And it's supposed to send 4 astronauts to the Gateway, and 2 of them are supposed to go to the lunar South Pole. A rover will be sent to the Moon ahead of time at the landing site, so they'll be able to use that to trek around all over the surface. And forays from the lander from anywhere from 5 to 15 kilometers away are planned into permanently shadowed regions on the Moon, so that we can start getting resources together. Depending what we do next, obviously depends on what we find and how easy it is to get some of the resources that we think we're going to need. But we want to get that permanent outpost landed on the surface of the Moon around 2028 or so. And that pretty much covers where we're going with the next phase of our Moon exploration. It's really exciting to me, honestly, to think that there may be people on the Moon in 3 years.
Yeah.
Honestly.
Yeah, that would be amazing.
I know I'm old, right? I had to explain what the Cold War was because the Soviet Union hasn't been a thing for 30 years. But I'm old, but I am not old enough to have seen anyone land on the Moon in real time. I missed it. I barely missed it. We can look back, and it's kind of exciting to look back at the old missions and feel the sense of excitement about doing something like that. But we know they turn out okay, right? Because they're in the past. It'd be a whole nother thing, if you ask me, to watch it happening in real time and realizing that these people are doing this now and going through enormous risk now to try to increase the capability of what we can do as humans. And it's inspiring to me. I can't wait to see it happen.
Yeah, that is very inspiring. I agree.
That pretty much wraps it up from my point of view. Feel free to write in if you have any questions.
We had a ton of really great questions.
Great.
When you were talking about drilling for the methane to help possibly get fuel for in the Moon,
Right.
Crystal was wondering, how do you think drilling for methane might affect the Moon?
Affect the Moon? Well, the methane that would be on the moon would be bound up in other minerals. We'd have to chemically separate it from those minerals. It's not like we're going to be drilling and then all of a sudden we'll hit a pocket of methane and there'll be this boom, like there might be here on Earth. It's a question of finding the methane that's bound to other things and figuring out ways to release it. Keep in mind that the moon doesn't really have an environment in the way that we're used to thinking of environment. It's a dead rock.
Yeah.
We say that, I say that, but life is kind of surprising even so. One of my favorite stories about our first foray to the moon was Apollo 12. They landed near an unmanned lander that had been sent 3 years prior, Surveyor 3, and they wanted to return pieces of Surveyor 3 basically to figure out how does stuff age on the moon? What is I'm going to use the word environment. What does the environment of the moon mean to machines and to materials and other things? What can we find after something's been sitting there for 3 years? And they found out that a colony of bacteria had been living in the insulation foam of the camera of the probe for 3 years on the lunar surface.
Wow,
Not
that's
thriving.
so impressive.
Right, it is. It's amazing to me. They weren't thriving, but they were living there somehow for 3 years.
Yeah,
right. So anyway, I want to emphasize that the moon is a dead rock, but that doesn't mean that we can't be surprised every once in a while.
Yes. Things can still survive.
As near as we can tell, there is no living environment to impact.
Yeah, and so for follow up, Fergus was wondering. So in that case, the methane probably would not be renewable as we know it right now.
Right. No, it wouldn't. We would consume it as rocket fuel.
Yeah. All right, great. There is a question about so there have been a lot of questions about just like keeping astronauts on the moon for multiple years, and we're not quite at that point yet, right? We're still trying to keep them there for a few days.
No, but we've managed to keep people in space for over a year.
Oh, okay.
But not much longer than that.
Yeah.
The crew is supposed to be swapped out on the moon once a year.
Okay.
And in fact, that's part of the reason we want to create this habitat on the surface of the moon. It is to learn what it means when people spend long periods of time in space. Because if we're sending people to Mars, they're going to have a several-month trip on the way there, be spending close to a year on the surface, and then a several-month-long trip back. So the moon is a much safer place to figure that out, if that makes any sense. If something goes wrong, you're only a few days away from the Earth.
Yeah, definitely.
You don't want to have that happen when you're months away. So we want to know what it means to inhabit space for long periods of time.
Yeah. All right, great. Okay, we had a question from Anne about for the picture of the orbits. Why are there such extreme ellipses?
Well, again, the goal there is to try to get to a balancing point when you want the capsule. When you want the capsule to dock with the space station, you want the capsule to get there with as little energy as possible. So when it swings way out, it gets out to a balancing point between Earth's gravity and the moon's gravity. So you basically launch the capsule to the minimum height you can get it to, and let the space station take it from there. So that's why they're long and looping, and then it loops in close, so you can get a lander down there, nice and easy. Awesome. It's by design.
Yeah, so it's not just using the gravity of the moon; it's also bouncing with the gravity of the Earth.
Right, exactly. Yes.
Yeah. Okay, great. We had a question. A really good question from Nathan asking, how come we are putting so much work into this moon landing when before it took much less time?
Before it took much less time?
I'm assuming this is a politics question. Talking about like back in the 60s, like why is it taking so much time now?
Well, let's not forget that when Kennedy made his promise that we were going to land on the moon, it was 1961, and we didn't land on the moon until 8 years later. Right? So it did take a fair amount of time there. And honestly, I think that we were in a rush partly because our national pride was at stake.
Exactly. Yeah.
That tends to light the fire under people.
Yes.
Yeah, and our sense of national security as well. That's a very good point too. We wanted to, when you threaten American safety, they tend to band together and figure out what to do about the problem.
Mm-hmm.
And this was no exception. Honestly, I think that it's difficult to get people excited about it. I think that most people look at the moon, they see this sort of gray, lifeless body, and their first reaction is, "Yeah, we've been there, we've done that," and they don't realize we've only been 6 times. The moon has a surface area equivalent to that of North and South America combined.
Mm-hmm.
If you landed 6 helicopters in North and South America, would you consider the place thoroughly explored? I'd argue no.
Yeah, there's still a lot
There's still a lot to
explore.
figure out, sure.
Definitely.
Especially
Yeah.
if, again, we want to look at what it means for humans to live in space for good.
Yeah. And another, Doug in chat also brought up a good point that, like, initially we didn't intend on staying on the moon, and now we're
Right.
planning on remaining there. So it's like you need to plan a little bit more.
That's absolutely true. That's absolutely true. But even if I could point back at the 60s too, the whole point of the Mercury and Gemini programs before Apollo were to figure stuff out like this. We didn't know if it was possible for humans to eat in space.
Mm-hmm.
Right. We had to figure everything out. Was it possible for them to get outside the spacecraft and work? Was it possible for spacecraft to dock together in space? Was it possible for humans to spend days in space at a time? And we figured all that out with the Mercury and Gemini programs, and we had to. That's why they existed.
All right. All right. We also had a lot of questions about just in general becoming an astronaut and like how old you have to be to become an astronaut. Would you happen to know? I don't actually know the answer to that one.
Yeah, I'm not an expert on this by any stretch. From what I've been given to understand, obviously you have to be in good physical condition. And there are certain cutoffs. I know that I cannot make the requirements because my eyesight is terrible. I have it corrected with contact lenses, and there are certain minimum requirements for sight. I know I automatically fail them. If you aren't a pilot, and getting pilot experience obviously helps, then NASA often draws from pools of engineers and scientists and so forth, because we're still exploring this space. We want to this place. We still want to find out a lot about it. And so there are lots and lots of space missions figuring out stuff about space. And in the shuttle era, we also see it happening with SpaceX and with the Orion capsules. We're going to keep wanting to bring engineers who know how to build space stuff and scientists who want to figure stuff out on those missions. So that'll give you a leg up, certainly. I don't know. I don't know, though, the full list of requirements. Believe me, NASA is eager to let people know.
I would say check out NASA's website for that.
Yeah, absolutely. Absolutely. Go right to nasa.gov and ask them, hey, how do I become an astronaut? And then you'll get somebody saying, hey, let me tell you.
Yeah, definitely. And we had a question about possibly using helium for energy on the moon instead of solar energy. I'm not sure about that. Can helium be used as energy?
Well, that's a tricky thing. Let me back. They're nuclear plants, but not in the sense that we're used to thinking about them. I'll have to back up a step. Our nuclear plants that we use now start with massive atoms, and for atoms they're massive, and splitting them apart. Right, that's called fission. And when that happens, huge amounts of energy are released. We use that energy to boil water and generate electricity. Helium comes in a very small nucleus, and we think we can also get energy provided we can control the reaction. We've managed to do it in an uncontrolled way, sticking small atomic nuclei together, and that would also release huge amounts of energy. Rather than breaking a massive one apart. Helium, as we have it here on Earth, tends to come as 2 protons and 2 neutrons. It's what we call helium-4. The moon is exposed to naked solar radiation, which could occasionally knock a neutron loose and turn it into helium-3, 2 protons and 1 neutron. Helium-3, as it turns out, is really, really simple to get into the kind of reaction, comparatively to other ones, to get 2 of those nuclei to stick together and release energy. So it's thought that helium-3 would be in huge abundance locked into in the minerals of the moon. And if we can figure out a way to mine that and get a nuclear reactor that works by sticking atoms together to use it, then yeah, you could use it to generate energy on the moon, more energy than we could probably use for a long time. But the fuel would be right there for figuring out how to get the colony or whatever else you've got to work. a lot of research would have to be done in order to get a helium-3 reactor to work reliably in the first place. But yeah, sure, that'd be a wonderfully viable technology. And some have even suggested mining the moon for helium-3 and returning it back here for reactors back on Earth.
Yeah, so. Great. Yeah, that'd be really great. Okay, so Chelsea was asking, will going to the moon help us go to Mars one day? Which, yeah,
absolutely.
Yeah, like you were talking about, it's a really great opportunity to study how space affects like travel and things like that.
Sure, travel or our machines, the machines we depend on to keep us alive, or technologies for packing huge amounts of food. Believe it or not, part of the problem of getting humans to survive more than a year in space is the food problem. How do we keep even freeze-dried food fresh and usable by humans? But yeah, that's not to say that the moon and Mars are identical. The moon and the Mars are very different environments, but there are still many lessons we need to learn before we go to Mars, and the moon is going to supply a lot of them.
All right, awesome. Okay, and then we just have a general question: is Neil Armstrong's flag still on the moon?
Yeah, that's a very good question. When they lifted off, when the Eagle lifted off from Tranquility Base, Buzz Aldrin says he thought he saw the exhaust from the ascent module blow the flag over.
Oh no!
Right? No. It's also important to mention that the flag was not this exotic thing made out of space materials. It was a regular off-the-shelf nylon flag. And there have some who suggested that the dyes used in the nylon exposed to naked solar radiation for 50 years would have bleached all of those all the colors out.
So just like a white flag.
Yeah, it'd be this white flag on the surface now, assuming it hasn't been punctured by micrometeorites or anything like that.
Yeah.
It's an interesting question, and we don't know for sure, obviously, but who knows? It may still be standing. Those flags are for the most part, probably still standing. I'll tell you what, if our national pride is what got us to the moon in the first place, China has been landing automated rovers on the moon. If one of them knocked over one of the American flags, you can bet we'd be back in a week.
Yeah.
We're proud of our, I think, and rightly so, we're proud of our space program, and we want to be the best.
Yeah, definitely. And Adam was wondering, how do rockets store enough oxygen for people to get all the way to the moon and back?
All the way to the moon and back. Well, part of it is that oxygen is stored, especially in a partially liquid or frozen state. You may remember Apollo 13. If you don't get the movie, by the way, that came out in 1995, it's excellent and very, very close to 100% accurate. You have to go over it with a very fine-tooth comb to find the errors in there. But what made that mission go foul was that one of the slush tanks that held the oxygen can be held in a much more compact way if it's frozen or liquid. They had to stir it every once in a while to keep stuff from freezing up and gunking up the pipes. And the heater and stirrer that they had actually drew a lot more current than they realized it was, and it caused the oxygen in the tank to explode. It's a great movie about how they managed to get the astronauts to survive all the way back, and you should really check it out. I'm not going to tell you the whole story. It's great. But to answer the question, basically the oxygen all the way to the moon and back has to be stored. Let me rephrase that. Now that we know that there's water on the moon, water is composed of hydrogen and oxygen. It can be split apart electrically, right? Yeah. So one of the advantages of being able to find water on the moon is that it would also supply oxygen. It can also supply rocket fuel itself, because some rockets, including the SLS core, depend on liquid hydrogen to operate instead of methane. So we could find a potential rocket fuel there if the methane stuff doesn't work out.
Yeah. And the movie name is
Apollo 13. Yeah.
Apollo 13.
It's a real story.
To check out.
11, 12, 14, 15, 16, and 17 landed, but 13 did not. And that's because of that oxygen tank failure.
All right. And we have time for one more question. Let's go look. Do you know how many people have actually touched down on the moon's surface?
12 total.
12 total.
There were 6 missions.
Oh, yes, you did say that.
Yeah. And they've all been male. One of the big things that NASA is looking at is, we've launched women into space, but none of them have been to the moon. And they want to correct that problem.
which they're aiming to correct with Artemis III, correct?
Yes.
Yeah.
Yes.
So looking forward to that. That'll be fun. All right, great. Well, thank you so much, Matt. I have a quick last slide that I am going to show really quickly. And thank you. Okay, great. So yeah, so thank you so much for your presentation, Matt, and thank you all for joining us today. We hope you had a lot of fun, and thank you so much to our sponsor, the North Carolina Space Grant, and our members of the museum who help make events like Astronomy Days happen. If you'd like to become a member of the museum, you can join naturalsciences.org/membership. You'll get discounts on certain merchandise and things like that, and you get exclusive access to members-only events and things. There are a lot of great programs scheduled for the rest of this week. So we'll post a link in the chat for how to register for those. And we'd love to hear your feedback on this program to help us improve. So we'll also post the link to that survey in the chat as well. And if you register for the program, we'll email it to you too. And finally, the recording of this program will be posted on the Astronomy Days program page within the next few days. So check that out if you wanted to revisit any of the information that's in this program. And thank you so much for attending, and we hope you have a great rest of your day.
Sure. Thanks for coming. And feel free to email me too. I put my email in the last slide there. Feel free to email me if you've got questions.
Yeah, if you had any other questions,
yeah,
let us know.
Take care.